This is the homework assignment that has the 7-3 on it on the one half, or sorry, this half, 7-3. The other half had some other problems. We're going to start by going over this half first, these 10 problems, and then I'll go to the other side and do the other 13 problems. There's 23 problems, example problems on here. Okay, so this was the homework for second and third hour for over the weekend, or we did half of it. The rest, second half was homework. And then we're going to be doing that Monday in class for first, fourth, and fifth hour. So here's number one. Again, the first thing I want to do is draw the two triangles separately so they're easier to see. So we can visualize them more easily. Okay. So here, well, let's see, where do I want to draw these? I'll draw them all the way over here. So here's one triangle. Okay, that's going to be JKL. So JKL, that's 2 and 3. Okay. Second triangle is the big one, which is JM and N. Okay. The side JM is going to be 2 plus 4, right? The whole thing is going to be 6. This piece is 2, that piece is 4. That means the whole thing is, this whole thing here then is going to be 6. And JN is going to be 9, right? Add the segments together, segment addition, right? So this piece is 6, this piece is 9. So we have 3 ways to show that these triangles are similar. We have angle-angle similarity criterion. We have side-side-side and side-angle-side similarity. Can we get 2 pairs of angles? Probably not. So let's go to the next one, side-side-side. Do we have information on the 3 pairs of corresponding sides? We don't. We only have information on 2 pairs of corresponding sides, which leaves us with side, angle, side. Can we figure out if one of these angles are congruent? Yes, we can. Angle J is going to be congruent to angle J, right? They both share angle J. They have a shared angle, right? Just like we did with shared sides, we use the reflexive property, right? Because shared sides were equal in 2 triangles. Right, because they're the same thing and they're equal to each other. Same thing for angles. Angle J is congruent to angle J. We know that because of the reflexive property of congruence. Okay, so side, angle, side, right, has one angle, the included angle, and then we need to show that the 2 pairs of corresponding sides are proportional. So we have to set up our proportion. JK, so we want to set up our 2 ratios because a proportion is 2 ratios that are going to be equal, or 2 or more ratios. Okay, so JK corresponds with JM. Okay, so our ratio is going to be JK over JM. And then we also know that JL corresponds with JN. Okay, and if we're going to be able to show that they're similar, we have to show that they're proportional, which means we have to show that the ratios are equal. Okay, if these ratios are equal, and we know that we have the included angles are congruent, the pair of included angles are congruent, we know the triangles will be similar by side, angle, side. So let's substitute in the numbers and see if it works. 2 over 6. JL is 3. JN is 9. Again, the 9 comes because we're adding these 2 together. Right, the whole side is 6. The whole side is 9. Reduce the fractions. 1/3. 1/3. Again, put in your calculator, get a decimal, you get 0.3 repeating. 0.3 repeating. Okay, they equal each other though. That's the point. Since they equal each other, we know since the ratios equal each other, we know the sides are proportional. Okay. So sides are proportional. The included angles are congruent. So yes, they're similar by side, angle, side. Okay, our similarity statement. So let's call it JKL. Similar to, again, here's our little tilde. Similar to triangle JMN. Okay, JMN. Then they're asking for a similarity ratio. So our ratio was 1/3. This first triangle is 1/3 the size of this triangle. Okay, this is 1/3 the size of the big triangle. Or we could say the big triangle is 3 times bigger than the small triangle. So we could put 1/3 or 3. This triangle is 3 times the size of the small one. The small one is 1/3 the size of the large one. Okay, that's where our ratio comes from. Okay, number 2. Okay, the first thing I would do, if you can visualize it right away, that's great. But if not, let's split up the triangles, redraw them, and align them so their corresponding sides are clear to see. Okay, we want the corresponding sides to be very clear. So here is, we'll do it over here. Here's one triangle. Okay, that's going to be this one. So it's good. I'm going to rotate it. Okay, rotate it. So I'm going to bring R over. So this is going to be R, P, and Q. Wait, let's not do that. Let's rotate this one. Take P and rotate it down. So we have P and R over the top and the Q on the bottom. And that's going to be 4, 4, 6. Then we have the larger one, which is going to be P, S, and R. So this is this one, the 9, 6, and 6. And then I took, okay, and then I took this triangle and I rotated it down and put it up here. Okay, so PR, RQ. Okay, we don't have any information about angle, so let's not use angle. Let's try side, 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 because we do have information about all the sides of these triangles. So if we can show that the sides are proportional, meaning the ratio between the corresponding sides of each triangle, if all 3 of those ratios are equal, then the sides are proportional. So let's set up our proportions. We know that PR is proportional to PS. PQ is proportional to PR. And RQ is proportional to SR. So that's going to give us 6 over 9, 4 over 6, and 4 over 6. Okay, reduce the fractions. We get 2/3, 2/3, and 2/3. So the ratios are equal, meaning the sides are proportional. Okay, so if we use the side, side, side similarity, okay, we can show that by side, 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 since the ratios of all 3 sides are equal, the sides are proportional. And if all the sides are proportional, then the triangles are similar. Here's our similarity statement, PRQ. Again, there's 6 different ways we could have named this one. That's going to be similar to P, S, R. Again, much easier if you redraw them. If you can visualize it from this, that's great. This way will eliminate some of your mistakes, though. Much easier to redraw it, easy to see. PRQ, what corresponds to P is P, corresponds to R is S, corresponds to Q is R. Similarity ratio, 2/3. Okay, or 3/2. So this triangle is 2/3 the size of the large one, or we can say the large one is 3.5 times the size of the small one. The small one is 2/3 the size of the large one, or the large one is 3/2 is bigger than is 3/2 the size of the small one. Okay, that's number 2. Okay, number 3, it gives us some information about the angles. We can find the missing angles by using the triangle sum theorem, which says that the 3 angles of a triangle add up to 180. So if we do 180, we subtract 81 and 52, we're left with 47. Okay, and then we do the same thing here. 180 minus 47 minus 52, we're going to be left with 81. So angle, angle, we can use angle, angle here to show that the triangles are similar. Angle, angle similarity. Okay, we actually can show that all three angles are congruent. We only need to show that two angles are congruent. So angle A is congruent to angle F because their measures are equal, and angle C is congruent to angle H because their measures are equal. We also know that B and G are going to be congruent, but we don't need to do that. We just need two angles, angle, angle. Similarity says if we have two pairs of angles that are congruent, then the triangles are similar. So this is, let's call it triangle ABC. What corresponds with A is going to be F. Corresponds with B is G. And then C is H. Do we know anything about the similarity ratio? No, we do not. We just don't know any information about the sides to give a ratio. Okay. So we'll just leave it blank or put a dash through it. The triangles are the same shape, but different sizes, and we don't have anything telling us what the difference in those sizes is. Number 4. The right angle symbol here tells us that we have perpendicular lines. So if the lines are perpendicular, we also know that this is going to be a right angle. Okay, if we want to redraw it, okay, this is going to be T, this is going to be S, and this is going to be Q. Okay. We notice we have two pairs of congruent angles. So are they similar? Yes. By what reasoning? The angle-angle similarity. Okay, if two pairs of angles are congruent, okay, angle P is congruent to angle T, and angle PSR is congruent to angle TSQ. Two pairs of congruent angles, therefore the triangles are similar. So triangle TSQ is similar to triangle PSR. Do we know anything about the similarity ratio? We do not. Those triangles are the same shape. They're different sizes, but we don't know how different they are in size. We don't have any information for a similarity ratio. Number 5. Again, it's hard to align them. So the way I would align them is by looking at the lengths of each side. So if the triangles are going to be similar, then the two sides that have the smallest length are going to match up. The two sides with the longest lengths are going to match up, and the two sides that have the middle lengths are going to match up. So 6 would have to match up with 12. Okay, meaning that. But let me. So 6 and 12 would have to match up, meaning DF is going to correspond with JL. The middle ones are going to be 8 and 16, so DE has to correspond with JK. And then our longest ones, EF, is going to have to correspond with KL. And again, these are distances, so it doesn't matter which way we write it. JL is the same as LJ. Okay, they're just numbers. Okay, that's going to give us 6 over 12. 8 over 16. And 10 over 20. Reduce our fractions. We get 1/2 equals 1/2 equals 1/2. Since the ratios are the same for each of the corresponding sides, we know the sides are proportional. All three sides are proportional. We know by the side similarity postulate or criterion that these triangles are similar, meaning they have the same size The same shapes, but different sizes. Okay, how much different? Well, let's write a triangle similarity statement first. So let's call it DEF. Similar to triangle. What corresponds with D? Okay, D is between the smallest and the medium length. So it's going to be between the 12 and the 16. So it's going to be J corresponds with D. Okay, then we go from D to E. So we're going from J to K. And then we're going from E to F, which is the same as K to L. Similarity ratio is going to be half or 2. Okay, the ratio is half for all of them. So we know that this triangle is half the size of the larger triangle. Right, 16 divided by 2, 8. 20 divided by 2, 10. 12 divided by 2, 6, right? This is half the size of the large one, or we know the large one is twice the size of the smaller one. So 8 times 2, 16, 6 times 2, 12, 10 times 2, 20. Twice as large, half as large as the other one. Number 6. And number 6. So I'm going to try to pick up the pace a little. Okay, we have 2 triangles. They share angle G. So we know angle G is congruent to angle G. And we know angle LG, LH is congruent to angle GKJ. Right? So this is going to be yes by the angle similarity criterion. Okay, and then we're going to have triangle GLH is similar to triangle GKJ. And we don't know anything about the similarity ratio. Again, if you need to redraw them, okay, this is GLH. And then GKJ. 2 pairs of congruent angles. Number 7. Triangle ABC is similar to triangle XYZ. What does that mean? Well, it means that the angles are congruent, the corresponding angles are congruent, and the corresponding sides are proportional, meaning the ratio for each set of corresponding sides is equal. So here we have 2 sets of corresponding sides. We know they're proportional because the triangles are congruent, so we can set up our proportion. Okay. AB corresponds with XY. Right? AB corresponds with XY. AC corresponds with XZ. Okay, we can substitute in our numbers. So we're going to have x plus 3 over 3x plus 1 is going to equal 6 over 15. How do we solve a proportion? We have to cross multiply. Okay, so 6 times 3x plus 1 is going to equal 15 times x plus 3. That distribute, we get 18x plus 6. Distribute, we get 15x plus 45. Subtract 15x. 3x plus 6 equals 45. Subtract 6. 3x is going to equal 39. Divide 3. X equals 13. Is that our answer? No. We're looking for the length of AB. So 13 plus 3 equals 16. Okay. Okay, guys, pause the video if you need to look at it. Go back, rewind, whatever you need. I gotta move on to the next one. Okay. Number 8, if triangle CAT is similar to triangle PIT, okay, what is the length of P? So P is our variable that stands in for the length of TI. So They're giving us two sets of sides in each one. So we know CA and PI. Why would they use a P there? Whatever. It's, I guess, lowercase, uppercase, but all right. CA and PI are similar, so we can say CA over PI. Since we know the triangles are similar, we know the corresponding sides, the ratios of each set of corresponding sides are going to be equal. Because that's what proportional means. It means the ratios are equal. So CA over PI. And then we have AT. It's going to correspond with IT. Okay, substitute in our values. So 20 over 35 is going to equal 8 over P. Cross multiply. 20 times P equals 8 times 35. That's what, 70 times 4? 140 times 2, which is 280. Yeah, 280. Divided by 20. So P is going to equal 14. 20 goes into 280 14 times. 20 goes into 100 5 times. So 5 plus 5 and then 4 is 14. Okay, what are they asking for? The length of P. So P is 14. It's number 8. Number 9. Okay, triangle EFG is similar to triangle HJG. So we know we know EG is similar to HG. So we know EG, it's not similar. EG corresponds with HG. Okay, we also know that FG corresponds with JG. FG corresponds with JG. Because the triangles are similar. Okay, so EG and HG. So 2x minus 2 over 15. And then we have FG, which is 20, which is x plus 9 over JG, which is 20. Cross multiply. 20 times 2x minus 2 is going to equal 15 times x plus 9. Distribute 40x minus 40 is going to equal 15x plus, I don't know, 30 times 90, 120. Oops. No. I only did 8, 135. Subtract 15x. We get 25x minus 40 equals 135. Add 40. 25x is going to equal 175 divided by 25. X is going to equal 7. The question wants us to find FG, which is x plus 9. So 7 plus 9 equals 16. Okay, if we wanted to check, we could check our proportion. So this one, EG, is going to be 2 times 7, which is 14. 14 minus 2 is 12. Right? So we would have 12 is to 15, as 16 is to 20, which is 4/5. 4/5. So we know 16 is the right answer. Okay, number 10. Okay, if CAT is similar to triangle CAT is similar to triangle PIT, what is the length of TP? So CA and PI. And then we're going to have CT corresponds with PT, which is 6x minus, whoops, with PT. So we're going to have 20 over 28 equals 3x plus 7 over 6x minus 1. Again, these ratios are coming from the corresponding side. CA corresponds with PI, and then CT corresponds with PT. Okay, we get that from the name, the order that it's telling us. Cross multiply, 28 times 3x plus 7 equals 20 times 6x minus 1. 28 times 3, that's going to be 84x plus, I don't know, 28 times 7 is 56. 14 plus 5 is 19, 196. Then we have 120x minus 20. Okay, subtract 84x from both sides. We're going to get 36x minus 20 equals 196. Add 20. 216 equals 36x. Can we see this low? Divide by 36. X is going to equal 6, maybe. Yep, 6. What's the length of TP? So we want to do 6 times 6 minus 1, which is going to be 36 minus 1, which equals 35. So TP is 35. We want to find the other one. 3 times 6 is 18. 18 plus 7 is 25. So 20 is to 28 as 25 is to 35. So that's going to get down to 5 over 7. And then if we reduce this one by, 4? We're going to get 5 over 7. So we know we have the right answer. Okay. So that is the this half. I think I'm going to split this into 2 videos. So that's, sorry, this half. What are we at? 29 minutes? Yeah, I'm going to split it in 2 videos. Well, no, we'll just keep going. Okay. Then let's do the 7/3 half. Okay. 7/3. All the way up. All the way up to that. We're going to fly through this. I don't know. Okay. Let's back out. Let's go to, say, 2. We get it all in one? Yes, we can. Okay. So let's see if we can roll through these 13 problems. Okay. All right, so this is the 7/3 half. So this is the half that you have to do for homework. We did the other stuff in class, so if you missed it, you should have it now. This is what was homework. Okay. So explain why the triangles are similar. Write a similarity statement for each pair. So here we have angle A is congruent to angle R. Okay, and then we have vertical angles. So we know angle AXB is congruent to angle RXQ. Okay, so we know by angle similarity that triangle, it's called ABX, is similar to triangle RQX. Okay. The second one, okay, let's set up some ratios. So again, we want to look for the two smallest ones. So 9 and 12. So PM corresponds with WL. PX corresponds with WA. Okay, and then our largest sides, AL corresponds with XM. So 9 over 12. 12 over 16. And 15 over 20. Okay. All three of those fractions are going to equal 3/4. Okay. So they're all going to be the same. All right. Let's put a comma here. 3/4, 3/4, and 3/4. Since all three sides are the same, we know we can use side, side, side similarity. Okay. Triangles PMX is similar to triangle. So P is going to be W. Then we went down the short side. So we got to go down up the short side. That's going to be L. And then over to A. Okay. Again, pause it if you need to write this down or look at it more because I need the room for this one. Okay. Number 3, we have vertical angles. So we know that angle QMP is congruent to angle, what's it look like here? AMB. Right, these are going to be our corresponding sides, QM, and right, these sides are going to correspond, and then these sides are going to correspond. So Q is associated with A, M is associated, it corresponds with M, and then P corresponds with B. Okay, ratios QM. Again, QM corresponds with AM, and then PM corresponds with BM. That's going to give us 4 over 2 equals 8 over 4, which gives us 2 equals 2. Okay, so we have 2 pairs of corresponding sides that are proportional. Okay, because the ratio is equal, so they're proportional, and the included angle is congruent. So by side angle side similarity, we know that triangle QMP is similar to triangle AMB. AMB. Let me write that. Triangle AMB. This triangle is twice as big as the smaller triangle, or we can say the smaller triangle is half the size of the larger triangle. Okay, number 4. We can find our missing angles, so they have to all add up to 180. So 180 minus 30 minus 20 is going to give us 130. So we know this is 130. Okay. 180 minus 130 minus 30 is going to give us 20. So we know this angle B is 20. Okay. So we know all three pairs of angles are congruent because they have the same angle measure. So we can use angle similarity, okay, to show that triangle M and J is similar to triangle ABC. Those triangles are similar. Okay. Number 5. Okay, we have vertical angles, so we know angle AXB is congruent to angle CXR. Okay, vertical angles. Okay, and then we know, well, we know the sides are going to be proportional, and the reason is, say we know this side, let's call it W. If that side's W, this one is also going to be W. If this one is Z, this one is also Z. So W over Z, does it equal W over Z? Yes, it does. Since those equal each other, we know the sides are proportional. We can think about it with numbers too if we wanted. If we said this side, BX was 6, then AX is also 6. If we said CX was 3, then we know RX is also 3. So 6 over 3 is going to equal 6 over 3. Okay. So no matter what numbers we put in there, since they're saying these are congruent, and these are congruent, right? It's saying EX and AX are congruent, and CX and RX are congruent. We know the sides. It doesn't matter what those numbers are, they're going to be proportional. So we can use side, angle, side, right? Because two pairs of sides are proportional. These angles are congruent. So side, angle, side, similarity, which tells us triangle ABX is similar to triangle RX. See, or we could put CXR, because again, you can flip them or you can rotate them. This was like example 3, the side example from our notes. So side, angle, side, here's our congruent triangles. Number 6, it's the same type of argument here. Pick any number, say it was 5. AB is 5, therefore AC is 5, and BC is 5. Say XY was 4, XZ is 4, ZY then has to also be 4 because all the sides are congruent. Okay. It's an equilateral triangle. Okay, so then our ratios are 5 over 4, 5 over 4, and 5 over 4, which are all the same. And again, this would work for any number. We can generically do it, but those ratios are all going to be equal. Therefore, we can use side, side, side similarity. Okay, and then really you can name these triangles however you want because you can orient them however. So triangle ABC is similar to triangle X, Y, Z. Okay. We can also use angle here because what do we know about the angles of equilateral triangles? We know it's 60, 60, 60, and 60, 60, 60. So we could have used angle similarity would work as well. Then we could also use side, angle, side similarity once we know an angle. So any 3 of those is going to work for number 6. 40 minutes. Okay, 7 to 12. Actually, probably should be quicker because they are solving ones. Okay. So these, they're telling us they're similar. Did they tell us they're similar? No, they didn't. Wants us to find X. Hello? Number 7, we see we have 2 pairs of angles that are congruent. Right angle, these 2 angles are congruent, and then the right angles are congruent. Therefore, by angle similarity, the triangles are similar. Since the triangles are similar, we know the sides are going to be proportional. Okay, so we can set up a ratio here. This side, right, is going to correspond with the side with the 9 because it's between two angles here. Okay, and then this side and this side, so 5 to x. Cross multiply, 6x equals 5 times 9, 6x equals 45. Okay, divide by 6, x equals 45 over 6. Is that right? Well, we got a fraction. We should probably check our answer here. Okay, because I don't know if that's the right answer. So let's check and see if we did it right. We know that 6 over 9 should equal 5 over 45 sixths. Again, this is also going to equal, we can divide by 3, and we get 15 over 2. So it's really going to be 7.5. Okay. So, right, and that's going to turn out to be true. This is going to be 2/3 equals 2/3. So we know x is going to be 7.5, 45 over 6. Okay, so that one's good. This one. Okay, are the triangles similar? Well, we have vertical angles. Okay, so if we can show that these are similar, then we know the triangles are. We can use side angle side here to show that triangles are similar. So we have 8 over 10 and 12 over 15, which is 4/5 and 4/5. So yes, the triangles are similar by side angle side. So then we know all the sides are proportional. So what does x over 11 or 11 over x have to equal? X over 11 over x has to equal 4/5, right? So let's set up our proportion. 11 over x has to equal, we can just say 8 over 10. 11 over x has to equal 8 over 10. We don't need to do them all. Cross multiply. 10 times 11 is going to equal 8x. That's 111. Divide by 8. 11. Once. 31. 7/8. So we are going to get a fraction. Okay. So x is going to equal 111 over 8. Let's just double check to make sure that's right. So 11 over 11, 111 over 8 has to equal 4/5. Multiply by 8. That's going to be 88 over 111. Divide by 11. That's going to be 8 over... So we can divide by 22. Divide the numerator and denominator by 22 each, and we get 4/5. So we know we have 4/5. So we know that's going to be our correct answer, 111 over 8. Okay. Number 9, 2 pairs of angles are congruent. Therefore, by the angle-angle similarity criterion, the triangles are similar. Since the triangles are similar, the sides are proportional. So 7 is to 4, as 12 is to x. Cross multiply, 4 times 8, 4 times 12, which is 48. 7x, divide by 7. 48 over 7 equals x. Okay, we can check if that's right. 7/4 has to equal 12 over 48 sevenths. So multiply by 7 over 7. 12 times 7, was that 72? Nope, 84. 84 over 48. Okay, divide by 12, which is going to be 7/4. So yes, this is our correct answer. Okay, 84 over 48 is the same as 7/4. Okay. Number 10. Okay. Are the triangles similar? First off, are the triangles similar? Well, okay, let's redraw them. Here's our first one, 12, 15, and 17. And then here's our larger one, which is going to be x. 25, right? 15 and 10, the whole side here is 25. And this side is 20. Okay. We know by the reflexive property, this angle and this angle are congruent. Okay, so if you can show that these sides are proportional, these corresponding sides are proportional, we can use side angle side to show that the triangles are similar. Then if the triangles are similar, we know this proportion, this ratio is going to have to equal the same as the other ratios. Okay. So let's see if they're proportional. 12 over 20, 15 over 25, that's going to give us 3/5. And that gives us 3/5 if we reduce the fractions. 3/5 equals 3/5. So we know by side angle side the triangles are similar. Okay, which means that 17 over x is going to have to equal 12 over 20. 12 over 20. Okay, we can cross multiply. So 12x is going to equal 17 times 20. Which is going to be 340. I have no idea how many times 12 goes into 340. That's going to be twice, which leaves us 10. 12 goes into 100. Well, let's just leave it as a fraction. Okay. X is going to be 340 over 12, which is the same as 170 over 6, which is the same as 85 over 3. Okay. So X is going to equal 85 over 3. If we want to check and see if it's right, let's plug it in. Okay, so 17 over 85 thirds should equal 12 over 20. Multiply by 3 over 3. That's 34. 51 over 85. Let me just use a calculator here. What can we... 15, right? What did we do wrong? 51 divided by 5 is 3/5. Yeah, 51 divided by 17. So if we divide by 17 and 17, we get 3/5 equals 3/5. So we know this is the right answer, 85 over 3. Number 11. Okay, it's very similar. Okay, well, we're using the fact that they're parallel. So actually, I don't like number 11. We didn't talk about that. Okay, well, these lines are parallel. We know corresponding angles are congruent, right, by the corresponding angle theorem. So now we have two pairs of angles that are congruent. So now by angle similarity, the triangles are proportional. Okay, if we draw the triangles out, this is 4, this is 3. The large one, this is 8. This is 4 plus x. So 4 is to 4 plus x, as 3 is to 8. Cross multiply, 3 times 4 plus x equals 8 times 4. That's going to be 12 plus 3x equals 32. Subtract 12. Why are these all fractions? 3x equals 20. Divide by 3. X is going to equal 20 over 3. Okay. So x is 20 over 3. If we want to check it, let's check it real quick. Okay, let me erase all this. What, 4 plus 20 over 3. So that's 12 over 3. That's 32 over 3. So 4 over 32 over 3 should equal 3 over 8. That's 12 over 32. Divide by 4, 3/8 equals 3/8. Yes. So we know the answer is 20 over 3. Then number 12. Okay, number 12. Vertical angles. So we know by the angle similarity criterion that the triangles are congruent. Okay, if the triangles are congruent, the sides are proportional. So 12 is to x, as 14 is to 42. Cross multiply, 14x equals 504. 14 goes into 504. That's what? 3 times. So 3 times 14 is 28, 42, 84, 6. So 12 over 36 should equal 14 over 42. 1/3 should equal 1/3. Yep. So x is 36. Okay, last problem we have 52 minutes. Jeez. I guess it is 23 problems. So, okay. Natasha places a mirror on the ground 24 feet from the base of an oak tree. She walks backwards until she can see the top of the tree in the middle of the mirror. At that point, Natasha's eyes are 5.5 feet above the ground, and her feet are 4 feet from the image in the mirror. Find the height of the oak tree. So we know these angles, right? The angle she's looking at. We know we have right angles. Okay. Right, it's the angle she's looking at is the angle it's coming off of the ground. Correct? If I'm wrong, I'll edit the video and change it. Right, that makes sense, right? If you're looking the mirror, it's going to come off the mirror at the same angle you're looking. No. These angles are going to be the same. If you're looking at a mirror, it's going to come off at the same angle that you hit the mirror at, right? Like if you hit the sharp, it's going to come off. Yeah, so it's going to come off at the same angle. I think I'll edit the video if that's wrong, but okay, that's what's going to go. So by angle criterion, the two triangles are similar. So since the triangles are similar, the ratios are going to be equal. So 4 is to 24 as 5.5 is to x. Cross multiply, 4x equals 24 times 5.5. That is 96 plus 12, which is 108. Divide by 4. X is going to be 27. Okay, find the height of the oak is 27 feet. So the tree is 27 feet. I'll have to verify that answer. If it's wrong, I'll check it over. But that is that assignment.